Okay, so that's intersections of two planes. Okay, now I want you to think geometrically. Okay, how can two planes intersect? They could be the same. They could be intersect in a line. In that case, that would be how many points? 3, because our lines have 3 points. Or what else? So parallel. Or they could be, what do you say over here? Wait, say it again. I heard you say a word I want you to say again. Skew. Skew. So what would, yeah.
We just have a question because in many cases we just have one card plane.
Right, so how can you have two planes intersect in one point? How is that possible? Is that crazy? Two planes intersect in a point. What's going on?
It's an imaginary plane.
No, it's not. And there's an interesting answer. Okay? Okay, hang on. We're gonna come to an interesting conclusion here. You don't want to miss it. All right. So if you could have two planes that don't intersect, so they might be parallel, but were they always parallel, or is it possible that there's two skew planes? That's one question. And how can you have two planes intersect in one point? What's a possible explanation for that happening here? Somebody who... No, there's no infinity here. It's really a very finite geometry. I mean, there's only 3 points on a line and 9 points in a plane. So there's no infinity. But there is something different from this than from our usual... When you're thinking about two planes intersecting in a line, you're thinking about in our world, right? How is this different from our world? Did everybody hear that? Say it again.
There's 4 dimensions because it's kind of 4 choices we can choose for what direction to go.
Yeah, it's 4 dimensions, isn't it? It's 4-dimensional geometry. Your 4 characteristics, each one is a dimension, like an axis. So in 4-dimensional space, you could have two planes intersect in just one point.
So they start at the same spot and go off in different directions?
Well, I don't know. This is a model of it. So just picture it here.